Good evening, guys. Today I want to start a little series of tutorials on solar power, and the first one I'm going to do is basically, well, it's going to be the base for all the rest of the work, which is going to be a solar panel. And this is what we're going to try to accomplish during this tutorial. What I have here is a solar panel that is currently outputting 320 kilowatts an hour, and it's basically getting its energy from the sun, which is our directional light in the scene. And if I get in front of this and I cover some of the cells, you can see that the power generated drops, and as the cell gets exposed to the sun again, because my character is moving, the power rises again, and I can even put it completely in the shade and it doesn't generate any power. And the reason this is going to be a series of tutorials is because I want to use this solar power to then maybe power up some batteries that might be in radius of this solar panel, or power up some weapons, or, well, whatever else I want to do. I don't have a specific game in mind for this, but I think it's a cool tech to have if you want to do something with solar panel. So let's get started. I have here the project from the last tutorial, the thrusters, and I'm just going to get rid of all this stuff here because I'm not going to need it, because we're just starting from scratch on a new tutorial. So let's create, oh, I just realized this is a big mess here. I'm just going to create folders for this stuff. Let's put everything under tutorial 4, the shockwave. I can type. I don't think I have anything for the shockwave. Oh, I do. I have the effect for the shockwave. I'm going to move it there. The BP, I'm going to move it there. What else I have? I have some boosters. I don't remember. I think the boosters was tutorial 4. Okay, so let's do it like this. And I think this was tutorial 3. I might be wrong about this, but it doesn't really matter. So BP booster, BP booster burn, and go into the boosters. Let's create another folder. Let's make it tutorial 2, I think, killable trees. And let's put the branch, root, branch, BP3, BP killable. BP killable might be part of the health system, or maybe not. Maybe let's just go in there. And we have a cube. Let's make it a new one. Tutorial 1, health system. And let's move this guy in there. And that's it. So now let's create a new folder. Tutorial 5, solar panel. Let's just save everything. Okay, so what do I want, or what do I need for this to work? Let's start by creating a new blueprint. I'm going to call it, let's make it an actor. I'm going to call it BP solar panel, which is going to be the basis for our solar panel. Just going to open it up. Move it here. I would love for Epic to fix this. I would love for these kinds of windows to pop up in tabs automatically, but I'm not sure it can be done ever. So, okay, we have the solar panel. I'm going to take a couple of assumptions here. One thing I'm going to do is, well, first off, I'm going to add a box collision to this, because it's going to be basically a rectangle, or yeah, and this is going to be the collider for the whole thing, and I'm just going to add stuff underneath it. So I'm going to assume that all the static meshes that I put under this box that are called cell something are going to be part of cells, and I want basically the way I want to do this is have the solar panel be composed of various cells, and if some cells are in shade they don't get energy, and if they are in the sun then they get energy and they produce for the whole thing. So the way I'm going to do it is just by adding simple static meshes. I'm just going to start with one cell for now, which is going to be a static mesh, and let's call it cell 1. And the naming is important because later on when I'm calculating the power of the solar panel, I'm just going to get all the static meshes that start with cell. Let's make it a 1 meter cube. I'm just going to make it maybe 20 centimeters by 20 centimeters by 1 centimeter. So a really small thing. And I'm just going to go ahead and prepare some work so I don't have to come back to this. I'll just make these guys I'll make this in the proper position here because I already know what I want in terms of the composition of the panel. And well, I'll just add all the others basically to save time. So let's just duplicate this, call it cell 2. Cell 2 is going to be at 0, minus 11, still 0.5. It's going to have the same type. It's perfect here. Okay, cool. Now I'm going to duplicate this again. I'm going to call it cell 3, and you can see where this is going. I'm going to do this 6 times, so we end up with 6 cells total. And now I'm just going to duplicate these guys, and actually I'm going to select them all, and I'm going to move them, well, almost like so. Let's see if I can do this all at once. I can put them at 11. Yeah, perfect. So I'm just going to rename them if I can. Cell 4, cell 5, oops, cell 5, cell 6. And now I want to add a base to this. It's also going to be a static mesh. I'm gonna call it base, and it's going to be also the cube. Let's make it 0.675, 0.45, 0.71, and the position is going to be minus 0.5, just so it's under the cells. Now the reason this is really crappy to see is because they are really close together, and I would like for these guys on top to actually have a kind of a mirror, or a glass kind of material. So I'm going to construct that material. Let's go materials and textures. Material, I'm going to call it M solar panel. Well, solar cell, to be honest, which is a better name. And so this material, it's going to be a really simple material. It's just going to be translucent because I want it to be like glass kind of thing. It's going to be a constant 3 vector, which is going to be black. And now the only thing I want to do is actually well, not perimeter, I just need a constant. I might want to tweak this at some point, but not right now. So the opacity, I'll just put 0.95, and this is going to give us, if I compile, a nice kind of glassy black glass look. Well, if my computer responds, of course. Yes, there you go. So kind of a glassy kind of thing. Cool. So let's save this, close, and now I'm just going to assign this material to all the cells here. Solar? No, solar. There you go. So this is starting to look like a solar panel, proper solar panel. Okay, so more things I want to do. Let's see. I am going to need kind of a component that calculates all of this. Well, I don't need to, but it's nice to have stuff componentized, so the actor doesn't have all the codes inside of it and get pretty messy. So I'm going to create a new component. Let's see. Yeah, I'm going to create a new component. So I'm going to blueprints. Yeah, new blueprint class. I'm just going to say it's an actor component. I think it should be BPC maybe. Well, let's just call it BP solar cells component. And this is going to be the component that is responsible for handling the code to handle the cells and the power and all that stuff. It's going to do all that work for us. And so I know I'm going to need a couple of functions. Actually, I'm going to need like 4 or 5 functions for this. So I'm just going to... So, okay. So the idea is, on begin play, this component needs to do 2 things. One, it needs to find out where the sun is, because I want to store the sun's position to do the calculations for the line tracing on the cells. And 2, it needs to find all cells inside its owning actor. And then actually needs to do 3 things. It's going to calculate the max power based on the cells that we have. And then on tick, I want to basically at all frames calculate the power that is being generated. And I am also going to add some debug information before we have some UI for this. So those are the 5 functions that I'm going to need. Starting with finding the sun location. This should be pretty easy. I'm just going to call it find sun location. And this function, it's going to, let's get all actors of class in the scene. And this class is directional light. So we find all the directional lights that we have in the scene. And then I'm going to iterate this for each with break, because I want to break as soon as I find the sun. Find the sun. And I'm going to get the display name of this object. And I want to compare it to sun. And you know what? Is this a case insensitive or case sensitive comparison? Let's do case insensitive comparison. That's what I want, because I don't want to force anyone to call this sun with capital letters or whatever. You can just call it sun in whatever way you want. So now I want to branch off this. I'm going to say if this object's display name is the sun, then what I want to do is I am going to, you know what? I need a variable here, and I'm going to say the sun location is a vector. And you might have realized I just changed to the event graph, so I could add the variable here, but I think you could do it also from here. If you add variables, you're basically adding variables. You're basically adding member variables to the class itself and not to the function. So I could do it also from here. I was just being dumb. So what I'm going to do here is set, and if true, so set the sun location. And now I need to calculate the sun location. And the way to do this, the best way is to just get the actor rotation. Because if you don't know, directional lights, it doesn't matter the position where they are. The light is also always calculated from the rotation of the light. It doesn't really matter where the actual actor is on the scene. It only matters the rotation that it has. So if I get the forward vector for this rotation, then I basically get how to shoot from the sun, so to speak. I'll just multiply this by a very large value. Let's say minus minus 1 million. I just have to check if I'm not doing a boo-boo here. Yeah, minus 1 million will do. This will give us a nice position of the sun. And now basically I found the sun, so I want to break this loop so I don't continue and waste precious CPU cycles. I'll just make this a bit neater here, and that's it. So when the game starts, the solar cells component is going to try to find the sun and store a reference to its location. Done. So we can just put it here on the begin play, and that's it. Cool. Next thing I want to do is find all the cells that are in the actor. So find cells in actor. And this function is, we're going to need a variable to store these cells. I'm just going to call it cells, and I'm going to make it static mesh or object reference, and I'm going to change it to array. And these are our cells. So now to find the cells, it's actually pretty easy. First thing I want to do, I actually want to clear this array just in case it has something in it, because I think if you already have it, if you already have one of the solar panels in the scene when the game starts, cells will probably already have some pollution in there. And then I got into some issues while trying to do this, and I found that clearing it is always safer. So always clear an array if you can before. So I'm gonna do a for each on what? I'm gonna get the owner, which is actually the actor, in our case the BP solar panel, and I'm gonna get components by class. And this is actually what I want to do. So these are going to be static mesh components. There you go. So I just got all the static mesh components that are in the solar panel. But if you remember, we have a base, and the base is not a cell. So I need to actually make sure I only store the cells as our cells. So you can see where this is going. I'm going to get the object name, not the display name, because the display name is going to have, it's going to be different when it spawns in the scene. But if you do object name, you're actually getting this name here in the hierarchy of the actor components. So that's why I do get object name and not get display name. And I'm going to check if it starts with cell. And ignoring case, so I can put lowercase, doesn't matter, uppercase, lowercase, doesn't matter. And now I'm going to do branch here. And if this is true, so if this guy is actually named cell something, I am going to add this to our cells. And I'm going to do an add unique to make sure that just in case I don't add the same cell twice. And the asset that I'm going to add is this. Oh, I can't. Why can't I? Oh, because I think, no, cells is static mesh. Oh, but this guy is not a static mesh, is he? Oh, this is an actor component. Yeah, because this returns. Oh, I think it's because I created this before. So let's do another for each here, just to make sure that Unreal is behaving. And not this, and not. Oh my god, doesn't work. Oh, maybe I need to compile first. No, I am doing something wrong. Okay guys, I know what's wrong. So basically this has to be an array of static mesh components and not static meshes, because we actually have references to the static mesh component and not the, let's get rid of this, and not the, okay, I need to do this all again, and not static meshes. It's actually static mesh component. So that's why it wasn't allowing me to do that. And now we're getting the static mesh components, and Okay, finally I can do a get cells and add unique if true. And the thing I'm gonna add unique here is this guy, and now I can connect. Fantastic. So this is our function to get all the cells inside the actor. It looks pretty neat. Let's get rid of it and let's add it to our begin play. That's it. Another thing done. And finally, one final thing I want to do in begin play is calculate the maximum power that we have. For this, I need to do I need to add a variable that says how much power a cell generates, and I'm going to call this generated power per cell. It's not an array, and it's a float basically. And I'm going to compile this and save, and I'm going to make it default 5.34. And the way I got this value was I was researching a little bit about solar panels, and I saw somewhere that a typical panel of certain dimensions, it doesn't matter, it basically had, I think, around 60 cells, generates around 320 watts per hour. And if you divide 320 by 60, you get roughly 5 dot something something. And yeah, that's the value basically that I'm using for each cell. So if all cells are exposed to the sun, if you have 60 cells, you get 320. I'm going to cheat a little bit because I don't want to have to generate all this power. I don't want to have so many cells basically, but the way I'm going to do that is I'm going to add a cheating factor, and you're going to see this being used later. I'm going to add a cheating factor, and this cheating factor is going to be 10,000, just so I get the values out in kilowatts hour. Oh yeah, I was doing the math wrong, so I'm sorry. Yeah, I was doing the math all wrong for that. Or not. Yeah, 320 watts hour. But I want to see some kilowatts hour in there. So I did it like this. Don't hold it against me. I'm just cheating my way into this. Another thing I want to do here, I want to do another little bit of work ahead. So I'm going to create a generated power, which is going to be the total power. I want to hold this in a variable so I don't have to recalculate it all the time. And let's see, I want to know also, I want to store the max power, which is actually what I'm going to store next. And yeah, for now, let's go with that. So the calculate max power function that I'm going to create, it's actually pretty easy. Calculate max power. This calculate max power is going to do just one thing. It's going to set this max power. That's it. And then I'm going to add a return node here, and it does nothing else. And the way I calculate this max power is by going through all the cells, just for each. Oh, sorry, I just lied. Actually, what I want to do is I want to get the length to see how many cells I have, and I am going to multiply this by the generated power per cell, multiply float by float, and this is going to convert it to float. And after that, what I want to do is multiply again, this time by the cheating factor, and that's it. That's the max power. That's the maximum power that this solar panel can generate. Done. Next up, well, let's add it here. There you go. There you go. So currently we have all the cells that we have in the actor. We have the max power generated by the solar panel, and we have the sun location. So now we need to calculate the generated power at runtime per frame. So I'm going to create a function called calculate generated power. And this function, it's also going to be very simple. The reason I break this into functions is because it gets so much more readable than if you just do a big spaghetti kind of thing. I am going to create a kind of a I could do this with a local variable actually. I don't need to set. Yeah, let's go with a local variable on this function. I'm just going to call it p current power. Okay, and I'm going to start this by, well, I don't need to set it to 0 because it's going to be 0 by default since it's a local variable. Every time the function runs, it's going to be initialized with 0. So I'm going to do a for loop on the cells, and for each cell inside the cells, I am going to get the world location of this cell, wherever in the 3D space it is, not relative to the actor, but globally. And now I'm going to need a neat little function to calculate the cell power. And I'm going to create it now because I don't want to finish this without having it. I'm going to call it calculate cell power. And the calculate cell power, it's going to be very interesting. It's going to need I'm going to need to store the current cell position. This is going to be a vector. Oops. It's going to be a vector. I am going to set this to, okay, I need an input for this function. I need the actual cell position for this function. I'm going to pass it in as a vector, and I am going to store it in a local variable just for simplicity, because I want to do some debug line drawing and I want to store this information to use it in 2 places. And now I'm going to do a line trace by channel. Line trace by channel. And the channel that I'm going to use, it's not going to be the visibility. It's going to be a new custom channel that we're going to create. But first, I am going to get the P current cell position, and this is going to be the start of my trace, and the end of my trace is going to be the sun. I'm going to trace a line from the sun to the cell, to each cell afterwards. But for now, for this one cell that we are calculating, I want to ignore self because I don't want to have its own static meshes to interact with the trace. That's why I'm ignoring self. And let's forget about the trace channel for now. I'm going to continue this one. I'm just going to do a branch of this, which means that if I get a trace, it means that the light is actually blocked. So what I'm going to do in that case, I'm going to return immediately. And actually I want to add an output parameter called generated power, which is going to be the power generated by this cell. And in this case, if something interrupts the trace, I am going to generate 0 on this cell. Otherwise, first thing I'm going to do is I'm going to draw a debug line, and this is why I needed that that local variable is just to make it simpler here, and you don't see a lot of spaghetti kind of lines. So from the current cell position to the sun location, and I'm going to make it yellow-ish. It's like the sun rays or something like that. And then I am going to return, but I am going to return an amount of power. And the amount of power I'm going to return is the generated power per cell. And I am going to multiply it by the cheating factor. If I can click stuff, times float tau, and return this value. This is the generated amount of power for this cell. Now let's go to the trace channel. What I need to do here is I need to go to the project settings, and I want to search by channel, and at some point we have let's see, maybe trace. Yes, trace channels. I'm going to do a new trace channel. I'm going to call it light, and I say that by default all physics bodies block light unless otherwise stated. And now I can go back here and I just compile, and I click the trace channel and I say light. Perfect. Let's close this up. Let's close. And we're back to the calculate generated power, the bigger one that goes through all the cells and calculates. So now that we have a way to calculate the cell power, I'm just going to call that function, calculate cell power, and this is the cell position, the world location of the cell that we just got. And I am going to increase the current power by the amount of power that was generated by this cell. And this way I go through all the cells, I keep adding to this P current power, and now I set it, and I keep adding until it's complete, until I go through all the cells. And when this loop completes, means I went through all the cells, and P current power will hold the max power that we have. Well, actually the generated power that we have. So I'm going to set the generated power on completion, and what I'm going to set it to is the P current power. Right? Let's close this up, and let's call this function on the event tick, calculate generated power. Okay, cool. So now I want to have a way to see the power that is being generated. So I'm going to create a function called display generated power. This display generated power function is going to basically draw a debug string, yes, I knew I could find it. And the text location is going to be the owner, or the solar panel, basically. I'm going to get the actual location from this guy, and this is going to be the text position, and I am going to write to it the generated power, get, and I'm going to append. I cannot do it like this, but I can do it with write append. This is going to create a string. It's going to be our text, and I'll just put this guy here. It's going to convert it, and I'm going to say power. Cool. So going back to our world, I am going to, one more thing. So now I need to go to the BP solar panel. I need to add the component BP solar cells component. And in principle, I don't need to do anything. It's going to calculate the cells on its own. And let's see if that works. Oh, I need to add it to the scene. Let's add a solar panel in front of this guy here. Let's save this all and play. And I don't see any strings, I don't see any traces, I don't see anything. I just actually move this guy a little bit up. Okay, still nothing. That's fine. What I think is happening is that the general collider is blocking the light. So I'm going to go to the BP solar panel, to the box, and I'm going here to make it costume collision preset, and I'm going to say it ignores light. Still nothing. Okay, we might have to debug this. Let's see. How can we start? Let's start with the sun location. Well, I'm pretty sure if we couldn't find it, oh yeah, the sun location, haha, that is wrong, because we need to rename our light source to sun. Otherwise we cannot find the sun location and the whole thing fails. Yes, perfect. So the rays seem to be okay, and they get interrupted if I get in front. There is an issue here, and I'm going to explain it in a little bit, but it has to do with the capsule collider of the character, which we need to set to ignore light and set the mesh collider actually to work. But it is doing something. It's just not printing the debug string. Oh, because we forgot to add it. Yes, we forgot to add it here. Display generated power. There you go. And ooh, nice. We are generating power. I have no idea what that amount is, but if we divide it by 10,000, which we did, it's going to be 32.04, which I guess it's roughly right. 5 times 6 is 30. There was like 0.34 on each. Yeah, sounds good. So we are generating power. And if I get in front, I can see that the power reduces based on the number of cells that are being hit. Cool. I think I'm going to stop here because this is getting a bit long. Next tutorial, I'm going to continue this, and I'm going to add a little bit of UI like you saw in the beginning to make it a bit prettier, and maybe even start... well, there's one thing I want to do actually. I mentioned that the third-person character has a kind of a capsule component to it, which is actually interrupting the lights and the rays. And I don't want to do it like that. I want the mesh to actually do that. And the reason, the way I'm going to do that is I'm going to the capsule component on the third-person character, and I'm going to change the collision preset to costume. Well, maybe I can do it here. No, I cannot. So I'll change it to costume as well, and I'm going to say it ignores light. And if I go back now, as you can see, it still interrupts, but it's now based on the mesh and not on the capsule. And as this guy moves, I can see that like it can interrupt some rays and then uninterrupt again, which is pretty cool. Like his hand is getting in the way. So yeah, that's it. Next time I'll probably do the UI part and maybe starting on the battery and making creating basically a way for the solar panel to transfer energy to the battery and charging the battery over time. That's going to be real fun. So until next time, have fun guys, and thank you for watching.